Ready for another deep dive? Today we're tackling something pretty mind-blowing.
Mind-blowing is right.
I mean, imagine snapping a photo and boom,
Uh-huh.
you have a full 3D model
I know.
in just 5 seconds.
It's incredible, isn't it? 5 seconds.
That's what we're talking about today.
That's right.
5 seconds. We're diving into a paper called LRM, Large Reconstruction Model for Single Image to 3D.
It's a mouthful.
It is a mouthful.
Yeah.
But it introduces LRM,
LRM, yeah.
which is the first model to pull this off.
It's a game changer.
It's a total game changer. I mean, think about it. For years, researchers have been trying to figure out how to reconstruct 3D objects from a single 2D image.
Exactly. It's like trying to understand a whole mountain from a single postcard.
Exactly. It's like you lose
so much information.
You lose so much depth when you try to flatten a 3D scene.
That's the challenge, the depth information.
Onto a 2D plane.
You got it.
And traditional methods.
They were
They were often limited to
specific objects.
Certain types of objects.
Right.
And they relied on
very complicated processes.
Super complicated processes.
Yeah.
But LRM
is different.
It throws all that out the window.
Exactly. And what's really fascinating is how it uses this large transformer-based decoder architecture.
Okay, hold on.
Yeah.
Transformers, encoders, decoders.
You know, it's a lot.
It's a lot to take
So
in.
you break that down a little.
Okay, think of it like this.
Okay.
The encoder is like a translator.
Okay.
It takes the input image, right?
Mm-hmm.
And it converts it into a language that focuses on the object's shape, texture, and structure.
Okay, so it's like picking out the important details.
Yes, exactly. It's picking out those important details and turning them into tokens.
Yeah.
You can think of them as building blocks for our 3D model.
Okay, the building blocks.
Right. And then comes the decoder.
Okay.
Which is like the architect.
Your architect, okay. It uses these tokens, these building blocks, to actually construct the 3D model.
So it's like the encoder reads the image.
Reads it, yeah.
Picks out those important architectural details.
Yeah, I like some, yeah.
And the decoder uses them to build a 3D blueprint.
A 3D blueprint, exactly. That's a great way to put it.
Okay, I like that.
But there's more to it.
Oh, there's always more.
There's a secret weapon in LRM's arsenal.
Okay, lay it on me.
The encoder. It's not just any encoder.
Okay.
It's a pre-trained visual transformer called Dino.
Dino.
Okay. And Dino is special
because
it's been trained specifically to focus on structural and textural information within images.
So Dino's not just saying, hey, that's a chair.
No.
It's saying, that's a chair with a curved back.
Yes. And smooth wooden legs.
And a soft velvety cushion.
Exactly. It's all about the details, the specific.
Yeah, about the details.
And those details are crucial for building an accurate 3D model.
It makes sense.
Right. And this is where LRM takes a really interesting turn.
Okay, I'm listening.
The decoder uses something called a triplane representation.
Triplane.
Triplane, yeah.
All right, you've got my attention.
Okay, so imagine
3 planes, right?
Like giant sheets of glass.
Yeah, like giant sheets of glass intersecting each other at right angles.
Okay, I can picture that.
And now picture projecting the image's features onto each of these planes.
So it's like taking that flat image and mapping it onto a 3D framework.
Exactly. It's like creating a 3D blueprint, you know, with coordinates.
Okay, like a 3D puzzle, but the pieces are features instead of colors.
You got it. And then the decoder uses a sophisticated transformer network to learn how all these features relate to each other in 3D space.
So it's figuring out how to connect those features in 3D.
Exactly, how they all fit together to make a whole...
I'm starting to get it.
Good.
But how do we go from these triplane features to an actual 3D model that we can see?
That's where NeRF comes in. NeRF.
What's that stand for?
Neural radiance field.
Oh, okay.
But we can just call it NeRF for short.
NeRF, okay.
And basically what NeRF does, it takes those triplane blueprints, right?
Right.
And it fills in the gap.
It fills in the gaps, okay.
It predicts the color and density of every point in space.
Wow.
To create a complete 3D object.
So if the triplanes are like the structure,
the framework.
NeRF is like the artist painting the details.
Exactly. Painting the object point by point.
It's incredible.
Isn't it? It's like how our eyes perceive
the
world. Like
mimicking.
Yeah. By understanding how light interacts with objects.
It's amazing.
It is. But all this, remember, it happens in 5 seconds.
I know. It's still blowing my mind.
5 seconds. From image to 3D model.
It's wild.
And we can't forget about the data.
The data, right?
This is all powered by data.
Yeah.
LRM was trained on a massive amount of data.
Massive, okay.
From two main sources.
Right.
Objaverse,
which is a data set of synthetic 3D models.
so like perfectly rendered 3D models?
Exactly.
How
Perfect, pristine models.
Okay.
And the second source is MVImgNet,
MVImgNet, right.
which is a data set of real-world videos.
Okay, so it's got the perfect.
It's got the perfect.
And then the messiness of the real world.
The messiness, the imperfections.
Good. All in one.
All in one.
To learn from.
Exactly. That combination is powerful.
That's powerful.
It is. This vast and diverse data.
Yeah.
It's what allows LRM to generalize so well.
To handle all sorts of images.
Right. It's like a seasoned traveler
Perfect.
who's seen it all.
Seen it all, yeah.
You know, and can navigate any terrain.
Okay, so what kind of results are we seeing?
Impressive results.
Yeah.
Really impressive.
Give me the highlights.
So LRM can reconstruct objects from real-world photos,
Okay.
even with really complex shapes and textures.
So we're not talking about
Nah.
blocky, low-resolution models here.
No, no, no.
We're talking high fidelity.
High fidelity, tons of detail.
That's amazing.
It is. It preserves the nuances of the original image, both in shape and texture.
Okay, so it's not just getting the basic shape.
It's getting the details, right?
It's getting all the little details in there.
All the nuances.
That's incredible.
And here's the kicker.
Okay.
LRM can even infer the hidden parts of objects.
Wait, what?
I know, it's pretty wild.
So you're telling me
Yeah.
if I show LRM a picture of the front of a car,
Uh-huh.
it can predict what the back looks like.
It can. It can predict what's hidden.
It's like it has 3D X-ray vision or something.
It's like it understands 3D, you know?
Yeah.
It's not just copying what it sees.
Just filling in the blanks.
Filling in the blanks based on what it's learned.
This is amazing.
The research paper shows examples, you know, of LRM reconstructing animals.
What kind of animal?
Like giraffes and penguins.
Wow.
Accurately predicting, you know, the shapes of their hidden sides.
So it's not just learning from the data.
Right.
It's actually
understanding it.
understanding it, applying it.
Applying it, yeah.
That's incredible.
It is. But there are limitations.
Of course, every superhero has their kryptonite.
Right. No technology is perfect.
What are we talking about here?
So one limitation is that textures in occluded regions.
Occluded regions.
Yeah, the areas that are hidden from view in the original image.
Okay, so like the parts we can't see in the photo.
Exactly.
Yeah.
Those textures can sometimes be a bit blurry in the reconstruction.
That makes sense.
Yeah, it's filling in the blanks based on what it knows.
But it can't always be perfect.
Right, it can't always get every detail spot on.
What other challenges does LRM face?
Well, another limitation is that LRM uses fixed camera parameters.
Fixed camera parameters, okay.
When it's creating the 3D model.
Okay.
So if the photo you give it
Uh-huh.
was taken from a drastically different angle,
Okay.
the reconstruction might be a little off.
So it's assuming a certain viewpoint.
Yeah, like a standard viewpoint.
And if the photo breaks that assumption,
Things could get a little wonky.
a little wonky, yeah.
Yeah.
But I mean, considering it's doing all of this in just a few seconds,
Right.
these seem like pretty minor hurdles.
Yeah, relatively minor.
Yeah.
Especially given how quickly it's all happening.
Exactly.
And the researchers are already,
Oh, of course they're not.
they're not stopping there.
Yeah.
They're looking at ways to improve LRM.
Like what?
Well, they're thinking about scaling up the model.
Okay, bigger, better.
Bigger, better, more data.
More data.
And get this,
Oh.
they're even exploring ways to incorporate language into LRM.
Language. Like
Yeah.
natural language.
Yeah. Imagine typing in
Okay.
a cat sitting on a chair.
Uh-huh.
And LRM generates a 3D model of exactly that.
Whoa.
I know, right?
That's next level.
It's like turning words into 3D reality.
That's insane.
It's pretty amazing.
This is why I love these deep dives.
Me too.
It's like always pushing the boundaries of what's possible.
It's always something new and groundbreaking.
Yeah.
It's really exciting to be a part of.
But before we get too far ahead of ourselves,
Right.
let's take a step back
Yeah.
and see how LRM stacks up against,
Against the competition.
yeah, the other methods out there.
Okay, yeah.
The paper mentions point E, Shap E, and 1, 2, 3, 45.
Right. Those are
What are those, and how does LRM compare?
So those are all cutting-edge approaches to 3D generation.
Okay.
Point E, for example,
Uh-huh.
uses a diffusion model
Okay.
to create 3D point clouds from images.
Point clouds. Okay.
Yeah, imagine like a cloud of tiny dots in space,
Yeah.
each dot representing a point on the surface of the object.
So it's kind of like connecting the dots.
Yeah, connecting
Yeah.
the dots, but in 3D
In 3D, yeah.
with points in space.
Instead of on paper.
Exactly.
Yeah.
And then you have Shappy,
Shabby.
which also uses a diffusion model,
Okay.
but it generates the parameters that define the 3D shape.
So instead of building the model directly,
Yeah.
it's like providing the instructions.
Exactly. It's like a set of blueprints.
So, okay, I like that analogy.
And then there's 1, 2, 3, 45.
1, 2, 3, 45. Okay.
Which takes a different approach altogether.
All right, how so?
It uses a 2D diffusion model
Okay.
to generate multiple views of an object.
So, like taking pictures from different angles?
Yeah, like snapshots from all around.
Okay.
And then it uses those views to reconstruct the 3D shape.
So it's piecing together a 3D puzzle.
Yes, but with perspectives instead of flat pieces.
That's fascinating.
It is. It's a very clever approach.
So how does LRM measure up to all of these?
Well, when you put them head to head,
Yeah.
LRM consistently outperforms them.
Consistently?
Yeah, both in terms of visual quality
Okay.
and geometric accuracy.
So LRM is the reigning champ.
It seems to be.
What's giving it that edge?
Well, part of it comes down to that triplane representation.
The triplane, right?
Yeah, it's a very efficient way to represent 3D structures.
It's like a streamlined blueprint.
Exactly, a very compact blueprint.
So it's not just about having a huge, complex model.
No, it's about using that complexity effectively.
Working smarter, not harder.
Exactly. And LRM is trained from start to finish as a complete system.
Okay.
Which means all its parts learn to work together.
Makes sense.
Right. It's like an orchestra where all the instruments are in tune.
And playing together seamlessly.
Exactly. And that makes it more efficient and leads to better performance.
That makes sense, yeah.
But those other methods...
Like pointy and shabby?
Yeah, they're also large-scale models.
Yeah.
Trained on millions of 3D assets.
So why does LRM still outperform them?
Well, it's the choice of the triplane representation.
The triplane again?
Yeah, it really shines here.
Okay.
Pointy and Shappy rely on point clouds.
Right. Those clouds of dots.
Yeah, which are like scattered building blocks.
Okay.
They can represent 3D shapes.
Right.
But they lack the inherent organization and spatial relationships that triplanes provide.
So triplanes are like having a blueprint.
Yes.
With clear coordinates.
Oh, exactly.
And point clouds are like having a pile of bricks.
With no instructions.
No instructions.
That's a great analogy.
Thanks.
The structure of triplanes makes it easier for LRM to learn those connections between the 2D image features and the final 3D shape.
It's all about the structure.
Plus, LRM uses fewer tokens in its triplane representation compared to point-based methods.
So it's even more efficient.
More efficient, more bang for your buck.
That's what we like to hear.
Right.
It's not just the representation, though.
Right.
It's also about the training process.
Exactly. LRM's training process also gives it an advantage.
Okay, how so?
It's trained end-to-end.
End-to-end?
Yeah, meaning it learns all its tasks simultaneously.
So it's like a multi-talented artist.
Yes.
Who can sculpt, paint, and draw.
All at the same time.
All at the same time. Wow.
Shappy, on the other hand, has a two-stage process.
Oh, okay.
It's like having to pass the artwork between different artists.
Which can lead to inconsistencies.
Exactly. Things might not quite match up.
So LRM is like a solo virtuoso.
Yes. Creating the entire masterpiece from start to finish.
That's a great way to put it.
And that streamlined approach.
Yeah.
It's bound to produce a more cohesive result.
Speaking of training.
Right.
Let's go back to those data sets.
The data, yes.
Objaverse and MVImgNet.
Okay.
Can you tell us more about those?
Absolutely. So Objaverse is a massive collection of synthetic 3D models.
Right.
Covering a vast array of objects.
Like what kind of objects?
Oh, you name it.
Fair.
Furniture, vehicles, animals, tools.
Wow, so it's like a digital library of perfect 3D objects.
Exactly. A treasure trove for an AI learning about shapes.
It's like a 3D encyclopedia.
It is. Yeah. And then to balance out that synthetic perfection, we have MVImgNet.
Right, the real-world data.
Yes, this data set is all about real-world objects captured in videos with all their imperfections and complexities.
It's like giving LRM a taste of the real world.
Exactly, with all its bumps and quirks.
So it learns from both the ideal and the real.
The real, yes.
Which makes a lot of sense.
It does. This blend of data is key to LRM's robustness.
You can handle all sorts of images.
Exactly, because it's been trained on such a diverse range of data.
It's like a chef who's mastered both classic French cuisine.
Ooh, I like that.
And street food.
They can create a masterpiece from any ingredients.
Exactly. But all this talk about training makes me wonder, what can LRM actually do in practice?
Good question.
What kind of 3D models can it produce?
So the research paper showcases some impressive results.
Okay, give me the highlights.
LRM can reconstruct objects from a wide range of inputs.
Like what?
real-world photos,
Okay.
AI-generated images,
Oh, wow.
and even those perfect models from datasets like Objaverse.
So it's not a picky eater?
It can feast on any visual input.
As long as there's an object to reconstruct.
Exactly. And the level of detail it captures is remarkable.
So it's not just capturing the basic shape.
No, it's getting the nuances.
The textures, the essence of the object.
Exactly. The paper shows examples of LRM reconstructing objects with intricate geometries and textures.
Like what? Give me an example.
Like a delicate flower with its fine petals.
Okay.
Or a fluffy dog with its soft fur.
That's incredible.
It is. It's really capturing the essence of those objects.
And remember we talked about LRM inferring hidden parts.
Yes. That ability really shines through in the results.
Okay.
They have examples where LRM reconstructs a giraffe, a penguin, a bear.
All from single images.
All from single images.
And it accurately predicts the shapes of their hidden sides.
It's amazing, right?
It's like LRM has this deep understanding
It does.
of 3D forms.
It's not just copying what it sees.
It's filling in the missing pieces.
Based on its knowledge.
This has to have implications for all sorts of industries.
Oh, absolutely.
Like what?
Well, imagine the possibilities in e-commerce.
E-commerce, okay.
Where you could see realistic 3D models of products online.
Oh, that would be amazing.
Right. Viewable from any angle.
No more guessing how that sofa will look in your living room.
Exactly. You could virtually place it and see how it fits.
That would revolutionize online shopping.
It would.
What about gaming?
Gaming. Oh, yeah.
Think of the time saved.
The effort.
Using LRM to generate high-quality 3D models.
From concept art?
Yeah.
Or even real-world photos.
Faster production cycle.
More realistic environments.
That could be a new era for gaming and VR.
Absolutely. And it goes beyond those fields.
Where else?
Think about architecture and urban planning.
Oh, okay.
You could create 3D models of buildings.
Yeah.
Entire cityscapes from blueprints or aerial photographs.
That would be incredible.
It would?
What about historical preservation?
Oh, that's a great one.
Yeah.
Creating digital replicas of fragile artifacts.
Or damaged monuments.
Exactly. The applications are really endless.
And we've only scratched the surface.
We have.
Of the creative possibilities.
Yeah, imagine artists and designers using this.
Creating unique sculptures, interactive installations.
Blending the real world with AI-generated forms.
This is incredible.
It's exciting to think about.
LRM gives artists new tools to play with.
New ways to express themselves.
And with text to 3D on the horizon.
Oh, yeah. That's going to be a game changer.
The possibilities are endless.
Only limited by our imagination.
This is why I find AI so fascinating.
Me too.
It's constantly pushing boundaries.
Always evolving, always surprising us.
But with all this power,
yeah,
comes responsibility, right?
That's a very important point.
There are ethical considerations here.
Absolutely.
As this technology evolves.
Yeah, we need to be mindful.
Like what?
Well, as LRM becomes more sophisticated,
yeah,
how do we ensure it's not used to create deepfakes?
Or spread misinformation?
Exactly. Those are serious concerns.
That's a critical question.
It is.
And one that we need to think about carefully.
We need to be proactive.
Yeah.
About how this technology is developed and used.
Making sure it benefits society as a whole.
Absolutely. Open discussions and responsible development are key.
I completely agree.
It's up to all of us,
yeah.
Researchers, developers, the public,
everyone,
to shape the future of this technology.
And make sure it's used ethically.
And responsibly.
Well said.
It's a powerful tool.
Yeah.
With great potential.
Great power, great responsibility.
Exactly. But let's not get lost in the potential pitfalls.
Yeah.
This LRM research is a monumental step forward.
It is. It's mind-blowing.
It is. To think we can create 3D models
from a single image
in seconds.
It's incredible.
Oh, it really is.
Before we wrap up,
yeah,
are there any other key takeaways?
Oh, definitely. I think a really important takeaway is that LRM is purely data-driven.
Data-driven, okay.
Yeah. It doesn't rely on any predefined 3D templates
okay.
or complex calculations.
It's not following a set of rules.
No, it learns to reconstruct objects by recognizing patterns in the data.
So it's like a self-taught 3D artist.
That's a great way to put it. It learns by example, developed its own style.
That's amazing. And because it's data-driven,
yeah,
it can keep growing and evolving.
Absolutely. As new data sets become available,
LRM can keep learning.
Keep learning, keep improving.
It's not a static solution.
It's dynamic, always adapting.
That's pretty exciting.
It is. LRM represents a real shift in how we approach 3D reconstruction. It gives us this glimpse into a future where creating 3D models is as easy as working with 2D images.
So 3D is no longer a specialized skill.
Exactly. It's a tool anyone can use.
Anyone with a camera and a bit of imagination.
Well, that's the future I'm excited for.
Me too. And with how fast AI is moving, that future might be closer than we think.
It might be right around the corner.
Well, on that note, I think it's time to wrap up this deep dive.
Okay.
But before we go,
I
want to leave our listeners with something to think about.
I like it. Little food for thought.
If you had the power of LRM at your fingertips, what would you create a 3D model of?
Ooh, that's a tough one.
I know, right?
So many possibilities.
Endless possibilities.
I think I'd create a 3D model of a long-lost ancient city.
Like Atlantis.
Yeah, Atlantis, El Dorado.
Wow.
To be able to visualize those legendary places, explore them in virtual reality.
That would be amazing.
It would be incredible.
That's a fantastic choice.
What about you?
Tough one.
Yeah.
I think I would try to recreate my childhood home.
Oh, it's nice.
In 3D.
Yeah.
Capture every detail, every little nook and cranny.
Ah, that's sweet, like stepping back in time.
It would be amazing.
It would.
Well, those are some great choices.
Yeah, I hope our listeners will think about this too.
Yeah, give it some thought.
And if you're feeling adventurous, check out the research paper.
LRM, Large Reconstruction Model for Single Image to 3D.
That's the one.
Dive deeper into this world of 3D reconstruction.
There's so much to explore.
Absolutely. Until next time.
Yeah.
Keep those minds curious.
And those imaginations running wild.
That's what it's all about.